This is Software Engineering Radio, the podcast for professional developers, on the web at se-radio.net. SE Radio brings you relevant and detailed discussions of software engineering topics at least once a month. SE Radio is brought to you by IEEE Software Magazine, online at computer.org/software.
This is Josh Long for Software Engineering Radio. With me today is Andrew Clay Shafer. Andrew's studies focused on math and science, then he got into computers to support his wife in medical school, and soon thereafter started working as a developer for a venture-funded startup. He worked on the team that spec'd the Fusion I/O cards, an e-commerce software-as-a-service solution, before co-founding Puppet Labs and focusing on infrastructure and operations. Along the way, he became fascinated with agile software methodologies and was lucky enough to have access to Alistair Coburn and the Salt Lake Agile Roundtable. This had a big impact on his worldview and definitely influenced a lot of the ideas and practices that we now call DevOps. He later joined Pivotal to focus on Cloud Foundry and to continue that journey. Full disclosure, I, Josh Long, also work at Pivotal. So, welcome, Andrew.
Thanks for having me.
My pleasure, our pleasure.
I haven't listened frequently in the present day, but I used to listen to this podcast a lot back in 2008, 2009.
We find it's fairly cyclical. People listen, sometimes they disappear, and then they come back. It's always a good sign when they come back. So, today we're going to talk about this idea of the next generation platform as a service, whatever that means, if that word even holds water today. What is platform as a service? What do we mean when we talk about that?
Well, this is one of my least favorite words, and I've written a few blog posts and explained this in several different ways, but the main thing that we're talking about when someone says platform as a service, or even worse, they say PaaS, is a set of APIs for doing deployments that allows you to interact with pushing some artifact into some runtime that is usually going to do some work for you to keep it up and scale it. At least that's the way that it's usually defined if you look at things like the NIST definitions. Unfortunately, and we can talk about this a little bit more, the word became very nebulous, and so there's a lot of things that people claim are platform as a service or label as platform as a service, which aren't really the same thing. So it's hard to compare apples to apples. And then I think there's an emergence of a new thing, which is when you think about the APIs that allow you to do these deployments, and there's a bunch of examples, and people will hold up things like Heroku and App Engine and Azure, some of the first movers in the platform as a service space. But those things, by virtue of being services, are also applications. And what does it take to deploy and operate those? What does it take to put the full lifecycle management into those as a service, the platform itself? And I think that's some of the work that we're trying to do right now.
Is that something that is typically taken care of by something like infrastructure as a service, or where does that meta management come in?
I think infrastructure as a service, while it's in some sense bleeding or has bled into what people originally called platform as a service, it was a little more narrow definition. So infrastructure as a service typically refers to the APIs that will give you access to things like virtual machines, some storage primitives, networking primitives. The de facto standard quote-unquote infrastructure as a service is really Amazon, EC2, Amazon Web Services, but then you also have some relatively advanced offerings now from places like Microsoft and Google, and then there's a whole host of other smaller kind of niche boutique infrastructure as a service or cloud providers. So all of them are doing different things, but I think it's fairly common to be able to expect to get VMs back and some control over networking and storage.
But do those things that we talk about when we say infrastructure as a service, are they what you're referring to when you say that there's something that has to manage the platform itself? What is that piece?
So in the course of my career, I've been lucky enough because of some choice and some circumstances to to see some very impressive web infrastructure and participate, both as a developer and an operator, and in some cases, almost like a business owner. But the typical management of those things has to be provided by something else. So if you're running an application, you have this full life cycle of things you have to deal with. And I think one of the things that this represents, at least in my mind, is the transition from software as something that was shipped on CDs to software that runs on a server, that is provided as a service. This thing we call the internet that's transforming everything. We kind of take for granted now that if you're talking about software, you're talking about services. When people say software is eating the world, and I've been one to say that as well, as kind of a narrative to support a point. But the real thing that's happening is this convergence of the network with the compute power, with the connectivity. So the software didn't all of a sudden get hungry. Software eating the world is not a new thing. We've had software for decades. What's new now is we're all connected to this fabric on the network with relatively cheap compute power, and most of us have what would have been supercomputers a few decades ago in our pockets. So that's a very interesting time to see that. And so at the point where those things are services that have to run on servers, they need to be running or they don't exist. Software as a service that is not running, it does not exist. It's not anything. It's nothing. So I think one of the things that represents is a transition to recognizing the full role of operations, the full role of all these things that have to happen. So it's not just about deployment. Deployment is the ante. Deployment's just the baseline price you pay to get to the rest of the problems you need to build the rest of that stuff and deliver value.
I see. When you first said that there was something beyond the thing that was just running the applications, I was expecting that to be some sort of discussion about, for example, Bosch. And now I see that you actually had a much larger. Bosch is, of course.
We can come back to Bosch later, but Bosch will fill certain roles. It is, in the parlance of the day, with the rest of the kind of DevOps tooling, it's a bit of a configuration management mixed with some orchestration, mixed with some health checks. So that gives you some of the pieces to do the lifecycle management. But there's really a checklist of things you need to be able to do to do this in a mature way. You need to be able to put code onto the servers and get it started running. You need to be able to have some baseline monitoring and metrics. If you don't know anything about your apps that are running, and at the point where you have a non-trivial app, you might have hundreds or even thousands of nodes that are doing work. If you can't get some insight into that at a glance, then you're totally flying blind. And at the point where something is wrong, when the customers start calling you because the application's down, where are you even going to start? So over time, this is sort of also represented a transition from. There's the transition from CDs to services, but there's also a transition from what I'll call ITIL. These really policy-heavy, top-down heavy frameworks for doing service management to the DevOps style of service management that we're seeing. And to me, DevOps just really represents the best practices and the tooling and processes and cultures that emerged from high-performing teams working to go faster and safer. And it's really about both of those in equal proportion. If you're going faster but you're not actually stable, in stability in this sense is different than the old thinking, which is minimizing the number of incidents. In the new model, the DevOps model, it's really about minimizing the time to recover. And if you can get the time to recover from something close to zero or zero, then it doesn't matter if you have an incident because your recovery time is so small.
That's a very mature perspective. Things will fail.
Well, then you take it a step farther and you introduce things like the chaos monkey, which is actually systematically destroying things, causing failures.
At 9 to 5, though, when somebody can intervene.
Well,
hopefully.
Right, but if you ever have an actual outage from those types of failures, then that's a bug that gets remediated, and you should never have that same failure again. That's why you run these types of destructive processes or do the drills, do the game days, is so that when that happens for real, like it's not for real because it's nothing. It's your software is taking care of itself. There's also, I mean, this also relates to a lot of stuff we could talk about with the frameworks we're working on. But there's a notion of self-healing. So if you've built things a certain way, particularly if you've done sensible things to manage state, then you can lose a significant fraction of your infrastructure with no impact to the customer, no impact to the service.
So, for the audience, the Chaos Monkey refers to a set of software released by Netflix designed to systematically destroy random vectors of the system, including hard disk access, network access, being able to just kill random processes. It does random things on running machines for Netflix.
So it's a little bit Amazon specific. It's part of the Netflix open source, and now there's the Simian army. So there's the first was this Chaos Monkey that does what you're describing, but now there's things that do they inject latency, they do whatever things that might perturb the things, and you just want to understand the application in a way that you can relate to it. There's I forget his name, but it's one of the authors of Erlang who has a great quote, and we could go look it up and put it in the notes. But he made a comment that it's not Joe Armstrong, it's the other one. He said that if you don't experiment before you go and put things into production, then production is always an experiment. And I think a lot of people live that day to day, every day.
The fear. Well, that's a natural segue for the next point. Moving to production, one hopes, is friction-free and it should be predictable. We should have some sense of what is going to happen, and DevOps is a big part of that.
Production deployment should be a non-event.
Right.
That's what we're striving for.
And a couple of things. I think, first, this idea of having a consistent workflow for going from development to production, from the developer perspective and the operations perspective. From the development perspective, what does development look like locally? What does it mean to deploy an application that is consistent in production on something like a cloud, like a platform as a service? What does it mean to describe how that application lives?
This is a very broad question, and there's certainly the way that some of the technology we're working on does things. The original platform as a service that you had with something like Heroku, then you have an artifact, which is some bits of code, and you push it into the system, and the system basically, and it was all, Heroku is all based on essentially Git repo. So you push a thing into the Git repo that's your Heroku repo, and then Heroku has some events that get triggered, and it does analysis of what that is, and then it decides that it is a Java application or a Ruby application, and then it does the right thing to bring that up, and then you have some knobs for being able to scale things up and down. But in that workflow, there really wasn't necessarily desktop deployment and then a production deployment. What you would typically do working with that model, and some of these things have built-in. So it's like Ruby and Rails have sort of built-in testing models that you run locally with the server. Java has very similar things depending on what you're using. The IDEs support all this stuff. And there's kind of equivalents for all the different stacks. So the actual testing would typically be pushing to another environment that was your test environment, but it would still be that remote cloud platform that was going to provide the environment and then run whatever. So I think one of the things that was missing a little bit here, and maybe this will be obvious to the audience and maybe it's not, is that this whole thing is sort of founded on great hygiene and development practices, starting with not even 12-factor, but just version control, testing. I don't know if you want to get so religious about test-driven development as we are at Pivotal, but it's reassuring to have some algorithmic way to verify that things are correct before you put them into production. And if you look at the models people are moving to now with stuff like the continuous delivery models, then if you don't have continuous delivery based on a fairly solid foundation of continuous integration, then pushing things to production faster is probably not doing yourself any favors.
You can hit walls really fast.
Yeah, you can bring everything down because and if you've never, I don't know. I mean, I crashed applications more times than I could count over my career. Typically, I also was able to recover most of them rather quickly, but the things that humans assume are not always correct. And if you can codify that and protect yourself with your own test suites and code reviews and the rest of this sort of hygiene that people will, and it gets a little religious, but there's sort of patterns of success, and one of them is really testing and hygiene and having like a nice foundational workflow. And this is before you get to something like the architectural implications of 12-factor or some of these other things. I don't know if that's too much jargon for people. We should probably explain what that is if we're going to.
I want to revisit that idea of local development that you can trust will look something like what's going to happen in the production environment, whatever that means. In this case, we're talking about a cloud. You're not going to run the whole thing locally, at least not right now. And so you mentioned Heroku earlier. They put forth this set of principles, these guiding principles that you could use to build applications that were divorced from their environment, and you could easily move them from one environment to another. Things like exposing services like databases and so on as backing services. This is of course the 12-factor manifesto. Is that the only way to do it these days? Are there other ways to get a consistent feel?
It's certainly not the only way to do that. So if you frame things against the 12-factor model, and that's a big part of the stuff that goes on with some of the stuff we're doing with Cloud Foundry and Pivotal, obviously. But the real thing that does is it allows you, as the operator of something like Heroku, to make certain promises. So the 12-factor manifesto is really representing a contract between the expectations of the application and the platform. And if you are going to do things that adhere to that contract, then you get these other benefits. And if you want to do things that are outside that contract, then you can't really use the platform. Or you can't use the platform as effectively, or it leads to these other failure things. So obviously the thing that people coming from some of the older app server models, they initially trip up on things like sessions and how you deal with state and these other things. So the clean separation between a stateless container, which you can essentially scale horizontally at will, you can afford to lose them. If you don't have session state, then anything can serve. It's basically like a functional request. So the replacement of the container with another one is transparent to anyone. Like no one even has to know if bunch of them disappear. So that contract gives you a bunch of constraints on one hand, but it also gives you a lot of operational advantages on the other.
Right. And so that, for example, the film between the application and its environment becomes vanishingly small. It's just these environment variables. It becomes configuration files, things that are easy to duplicate on my local machine as well as on some sort of platform as a service or some sort of runtime. What additional benefit does having something like a container give on top of that? Why would I need a container?
Yeah, sure. A moment ago I mentioned that the first generation of these were really about pushing code into some fabric, and then it would build a stack. And Heroku's actually been based on Linux containers for a long time. So under the hood, they were using that. But then recently, it's become popular, and I'm actually fond of this. And people usually refer to this approach as immutable infrastructure, which is that you package the full machine image, so you kind of get yourself out of the dependency management problems that a lot of people have dealt with, and it really represents a failure of us to solve the shared library problem in a meaningful way. But by packaging up the actual all the dependencies in one deployable artifact, then you get a bunch of advantages with consistency. And then the only difference there is, and you still don't get rid of all your problems or having differences between the different environments, but you're able to guarantee that at least the bits on the disk are the same, and that they'll behave modulo some environment variables. Obviously, if you don't connect them to the right databases, or you do silly things in the environment that has a bunch of conditional logic in the code, then you kind of run yourself into problems. And I always thought it was I worked on products before, and I always fought with people about logic in the code where they're like the application knows what environment it is in, I always thought it was a terrible code mill, and I always work very hard to try to remove those or encourage people not to do that. But I think anytime your logic has to know what environment's in, then you set yourself up for these catastrophes where you're on a totally different code path in production as you are in test.
And by definition, something hard to test.
Right, because you like went out of your way not to test it.
Right. When we talk about containers, I think maybe we leapt a little bit further ahead. What is a container, Linux container? What does that refer to?
So this is something that was really accessible. It's been in use for a while and accessible to anyone who's sort of a systems person. And actually, it's worth mentioning a little bit of history. So there's a bunch of stuff going on with virtualization, and most people sort of understand what virtual machines are and what a virtual machine is. And I don't want to get too into the weeds with the nuances of paravirtualization versus whatever, but you essentially have a way that you're emulating the hardware, and then you run an operating system on top of that emulation. So hypervisor is providing interfaces that for all intents and purposes, or most intents and purposes, look like a machine, and then you boot a new kernel, and you're able to run Linux or Windows or whatever. And I think most people, or a lot of people, are familiar now with the cloud offerings, and those are using virtual machines, or you maybe are using Vagrant or some local virtualization to do things. And it's nice. Like I can. People used to do dual boots on their laptop. I don't see a point of doing that now because I can run in Fusion or one of the VirtualBox or some of these other options. I could run Ubuntu or Windows or whatever I need as a virtual machine. I don't need to go through and set up the actual booting on the physical hardware. And then at some point, and this is in the Linux world, this didn't get into the mainline kernel until 2007. It came from Google. So the stuff people are calling Linux containers right now are really about C groups and namespaces and some other functionality to do quotas and some of this stuff. But it's basically features of the Linux kernel that isolate the access to resources and visibility. So the C groups are functions, and it all looks, under the hood, it all looks like this file system, because everything in Unix is file. And you manipulate things, and you set up these hierarchies of limitations on things like CPUs and memory. And then namespaces have to do with visibility. So a collection of these hierarchies of C groups and namespaces set up an environment where a process that you start on that machine under those C groups and namespaces looks like it's the only process running on that system. And the C groups and namespaces are combined with these root file systems. So if you've ever used chroot, or this basically a new mount point. So you say that you want to start a new process under the C groups and namespaces, so you're getting isolation and limitations on visibility and access to resources, and then you're going to start them on a new root file system. So that looks like it's a new machine. You can't see anything above wherever you're mounted in whatever you kind of mounted as a new file system is your root.
So the same mechanism that Unix uses to mount a disk drive, for example, you're mounting a virtual file system, so to speak?
Well, you're mounting it, but you're actually switching the root. So nothing beyond what you just mounted is visible to you in the file system.
Right.
So if you think about what's happening, and what I see is a lot of exuberance around projects, and particularly Docker has a lot of adoption. And to me, that is a usability bug that they were able to fix that made this technology accessible to the average developer who might not have had the background or the patience to go and figure out all the stuff to set up the root file system and process management. So with some sensible defaults and some tooling, it's relatively straightforward to get your default Docker container running with kind of whatever you want in it. And it's a pretty nice workflow that is social. So that's the thing that drove a lot of the adoption, is that you have this named index into these images that you can share across the community. And we do that a lot inside Pivotal, and we're using, we'll talk about Lattice maybe a little bit later, but just being able to have this social workflow where hey, I just pushed this thing, just like you have this transformation of open source, and the way people worked when you get GitHub and that socialized that work. That now Docker's socialized the sharing of these containers. So you can say, not, hey, here's this thing, go build it, but it's actually a packaged, complete file system that you can go run whatever application. So it's sort of becoming a new packaging system for sharing these root file systems. And then Docker also provides some tools to do the runtime environment and some inspection. And they're actually starting to work more on some more platform features as well. But that's the real big breakthrough there, was this usability bug and accessibility bug that let everyone use the containers. And consequently, this is a really interesting story if you think about it in the larger context, that Docker came from tooling that .cloud had insight into from trying to build a platform as a service. So they were funded to build a platform as a service, and they weren't terribly successful at getting a lot of adoption, but the insights that they had working on that led to what now has kind of become one of the more prolific projects. So there's other people working on other approaches as well, and I don't think it's a foregone conclusion that will be the only thing. But the fact that you have I think over 100,000 Docker images right now that you can go pull and have a bunch of stuff in them that you could run is pretty cool. It's and we do the Docker Hub stuff with some of our projects and some of our CI, and it's obviously a big part of Lattice as well.
Docker Hub, of course, is the repository you were referring to earlier that socializes these images, these containers.
Yeah, so what it does is it gives you this named index into that repository, just like you'd have a hash or whatever on your Git repos, and so then you can specify a new Docker. So you say like a Docker file that would say, here's my image, and you could start where you left off with the other one. So it gives you some workflows where you could, as a team, work off the same base image, or someone could do one part and then put it into the repository, and some other team could take and do whatever else they want with it after that. Like
layers.
Layers. It's actually it's built on the layering file system.
Okay.
It is very. That's the best way to describe it, because that's how it works. It's layers.
So these containers, is it now more practical to describe and develop your application in terms of a container locally? Does that further assure us that we have an identical behavior for development and deployment?
Well, it doesn't give you identical behavior. I mean, it depends on a bunch of the logic and scaffolding around it. So we already talked a little bit about the thing that people are calling containers right now is really features in the Linux kernel that are taking advantage of the tooling to be able to set up these runtimes on these root file systems, and it's really exciting. But then, there's a bunch of other stuff you have to do to solve deployment, and there's obviously pieces of that in play and some of the stuff we're working on. But if you think, so I used this metaphor in a presentation I just gave, and I think most people have seen at least pictures of the intermodal shipping container that people put on the boats and send back and forth, and they put on the trains and the trucks and the cranes and all the stuff that has to happen to make it. And there's a fascinating book called The Box. Someone thought this was interesting enough to write 400 pages about it. And the impact that had on global trade was, one, it was not really anticipated, the impact it has. Now 90% of the non-bulk transport goes through shipping containers. So there's still some transport where it's bulk transport of some good, some commodity like oil or grain or something that won't be on a shipping container. But most goods are going to be through shipping containers. 90% is the thing that I read. And those shipping containers, they were essentially the same since 1970 till today. But what has changed is the rest of that infrastructure and the scaffolding and the logistics to be able to take those things and put them on the ships more effectively, to take those things and put them on the trains, the cranes, the trucks, and then every single, here's an interesting thing, especially from the perspective of talking about doing these software deployments. Every shipping container has a number and they're tracked, right? So then how does that whole system evolve to, it didn't start out that way. And now we're getting to where, and this is happening right now, and some of the projects we're working on will probably impact this, but every container will be connected to a sensor network. And you could get to the point where, specialized containers have all sorts of things and guarantees and SLAs about temperature or, shock or whatever. And that evolution is not really stopping. So right now, what I think we have represents that intermodal container. So we're at 1970, and people are working to build the rest of those, purpose-built ships and trucks and trains and cranes to do the rest of the stuff the best possible way. And we made progress, and some of the stuff we're able to do right now is pretty impressive. But I feel like there's still a long way to go to get to I don't see the evolution slowing down, and it's pretty fun to work on it.
What does then, in specific terms, what does the 2015 version of the runtime, the software runtime, that isn't just about intermodal containers? What is that scaffolding? If you had to point at the thing that is mapping the progress you've just described in the actual shipping container industry, what does that look like today? Is that platform as a service?
I think it has platform features, functionality. If you get to the point where you're deploying the containers as the first class primitive, then we're there. But I still think there's a lot of benefits to some of the build pack and the code artifact methods as well, even if it ends up creating a container later, just because it gives you a little bit more control, especially from the perspective of doing things. When you have something like Ghost or Heartbleed and you need to patch an infrastructure, we run a massive platform as a service that has collapsed the complexity of solving something like patching Ghost to getting the patch, and in an hour later, all your containers and all of your virtual machines are all patched. And that wouldn't be possible if you didn't have a really great system for mapping that hygiene. So I think just getting the containers and putting them into a system and calling that good is one thing. But if you don't have the kind of the bookkeeping and the infrastructure and the logistics to manage them, like some of the stuff that we're working on, then you solve that first level deployment problem, but you still have a bunch of day two and going forward problems that remain unsolved. And you're right back to the same type of procedure that you'd have today if you had a bunch of virtual machines and they're all deployed and you didn't have great inventory of what images and what patch sets are on them. Now all of a sudden you have Heartbleed. What do you got to do? You got to go, and it ends up being a long week for many organizations.
Auditing every container, worst case.
Absolutely. Spelunking.
You mentioned a build pack. What does that specifically refer to?
This goes back to Heroku, and it's in some ways. So I have a quote. I put it on Twitter months ago, but I keep saying it now, and that is a sufficiently advanced Docker build pipeline is indistinguishable from a build pack.
Huh.
And basically, the idea of the build pack is that you push this artifact that you want to deploy, and that could be Rails or a war or jar or whatever. And then there's a couple steps that happen, and the first one is the detect phase, and this is straight Heroku. So the build packs that we use in Cloud Foundry are derived from Heroku, and most of them will work in both places. The only thing that doesn't work is if there's a nuanced difference in the underlying base images. So some of the dependencies might not work, but the detect phase will run some logic, and it will say, based on whatever, and it's some of it's like regex or the file types or whatever, and it figures out, okay, like this is a jar, so that's a Java runtime, and so then, and these are all configurable, so you could have it do whatever you want, but it's basically going to lay down something like Tomcat or Jetty or whatever you have it configured to do, and then and there's that stuff's evolving itself, and I know you know a lot more about that than I do. But then that Java stack is layered on top of a root file system, running or not running, but a operating system, and that could be Ubuntu or Red Hat or the CoreOS or one of these others. And then the build pack lays down the stack, and then that cherry on top is the deployable artifact, and then that is put into the framework of the platform and then started. And that process happens, detect, and then the compile, and then there's some kind of like post-compilation steps to do some configuration. But
the output of that process, what is that? Is that a container, or what is that?
Well, it is actually a container. It's a root file system. The insight that the Docker had was, well, let's just make that a deployment artifact in and of itself and let people ship those around now that network and storage is relatively cheap. But in the past, and this is changing, Heroku, like, you didn't have a way to eject your container. So you pushed your Ruby on Rails code into Heroku, and under the hood, the build packs were making a container, and you had no way to push eject and like get that container back out.
So that meant that you were forever wondering what the final runtime result was always going to be different from what you had locally.
I don't know if that's necessarily true, especially if you're in a mindset where your local development is not that different than your production development, and then like all these things come down to managing dependencies, and or at least 90% of the problems people run into. So I think most people get into a point where like you have a pretty good iteration, your dependencies are in place in both your environments, and then you can iterate pretty fast. And then every once in a while, when people really run into problems, my observation is when those upstreams change, especially if you have, I don't know, like Ruby, you change one version of one gem and like a bunch of stuff broke, right? And it's the same for most of these runtimes where there's this chain of dependencies, and small inconsistencies or incompatibilities in those dependencies can cause this cascading failure. And I think you run into that with pretty much any stack.
Sure. Anything that resolves dependencies over the network, which is basically, they even have that for C now. So unless you're pinning your versions down, you're going to get in trouble.
Pre-container days, whenever I ran infrastructure, I never would pull packages from the internet. I always thought that the best hygiene, and I still advocate this pretty strongly, is to maintain local package. So then your deployment artifacts are controlled by you, and your change management process now includes rigorously testing and great hygiene to pull in those upstreams as you need patches, there's security, whatever necessitates changing those things. And the gating functionality is just to bring those into the local repositories, but you would never deploy anything that came right from the unfettered access to the internet.
Right. So that discipline to get that aforementioned hygiene, I don't imagine that's easy to come by. That's something you, as often as not, want hopefully that's something you can push to the platform to take care of for you.
I mean, one of my goals with all this, and this was going back to the Puppet days and the DevOps days and all the rest of it, the goal has always been to enable innovation, to enable the organization to deliver. So the thing that I want to get in a platform, and whether I'm building something from scratch with configuration management, or now with these more opinionated integrated solutions like Cloud Foundry, I want to make it the easy thing to do the right thing. Right? That's where people run into problems with hygiene, is when it's super hard to do the right thing. You have all these pressures to deliver. The business, I don't know anyone who's ever been in a software project where there wasn't some pressure to go faster or have more something.
And if that project exists, are they hiring?
Yeah, seriously. So then you have all these pressures to do that, to move you forward, and then someone's going to make it hard for you to do a bunch of stuff, and most developers will start to kind of color outside the lines if it's really, really hard to do the right thing, unless you have a kind of draconian culture, really highly regulated, whatever process, then most people are they're gonna err on the side of YOLO and do whatever they can to get things done.
Push the big red button. So you mentioned Puppet. Can you tell us a bit about what that is?
Oh, so Puppet is a project that I used to have. I spent all my time on it, and it's a configuration management tool that allows you to configure servers based on a policy. So you would write these Puppet manifests that describe how a server should be configured, and then that's its own language that has some rich abstractions around things like users and groups and files and all the things that really as like a system administrator should concern themselves with. And now it's even more sophisticated, and there's integrations to the networking gear and the storage gear and the rest of it too. But the model is basically that you have this declarative, role-based policy that specifies how servers should be configured, and then that allows you to maintain consistency across relatively large, relatively sophisticated servers. And it's a great tool, especially in a model where you're all about pinning the state. So the mental model for that generation of tools is really about getting a server into a certain state, and really, to be quite honest, keeping it there. It's about pinning the state, and that's great in a time when you had maybe not so many servers and applications were developed on top of them, but you weren't really trying to do deployments with the same basically violent frequency that you're seeing now with the continuous delivery models. And so when you get to the thing where you're trying to both go faster at a higher scale, then coordinating those declarative models across a large infrastructure, it can be done, and I've done it. It just requires filling in a lot of coordination and orchestration code so that you can do those deployments. And it's not purpose-built to do that like Cloud Foundry is.
So a platform as a service like Cloud Foundry, that is sort of the at scale version of that discipline?
It's not a question of at scale or not at scale. What Cloud Foundry is doing is shifting the primitive from being a server-centric primitive to an application-centric or service-centric primitive. So I don't think it's a question of scale. Certainly, I know Puppet and Chef deployments they're on the order of hundreds of thousands of servers.
Sure.
And they work great at the way the level they're designed, but then the actual integrated user experience to do deployments is very different than you're going to get from something like Heroku. And Heroku use some of these tools as well to build that, but then what's the user experience for the actual developer? What's the user experience for the operator? And what is that experience if you're not 100% familiar with all those tools, right? So it's one thing if you're an expert on a tool to make good use of it. It's another to kind of pick it up and use it the first day. What is that experience?
Does a Cloud Foundry or Heroku give you a smoother on-ramp and trade off a bit of flexibility? Does it trade off more power?
I think in many regards you have more flexibility with something like Puppet, but because you can do anything you wanted, right? Where what Cloud Foundry has done is collapse some of those options into this very opinionated cloud native 12-factor model, so that you're able to do the rapid deployment. It's a great user experience for the developer, and it's also more and more a great user experience for the operator, but it, in some ways, is less flexible.
Right. So before we get too far ahead, what are we talking about when we say Cloud Foundry? What is that today?
Cloud Foundry it's actually a fascinating story, and there's a bunch of things that I can't say publicly because I know too much, but and I wasn't involved in all this. I was kind of watching from the sidelines. I know a bunch of the characters, but Cloud Foundry started as a project at VMware, and the majority of the early engineers on Cloud Foundry had all kind of come from behind the veil at Google, and they were specifically hired to work on this deployment fabric. So they'd seen Borg, they'd worked on the Google infrastructure, so it's SREs and engineers that were paid quite handsomely to come work on Cloud Foundry inside VMware, and they worked on the first versions of what is now Cloud Foundry. But at some point internally, there's a bunch of politics and personalities, and so Cloud Foundry made its way from VMware into Pivotal, and Pivotal was spun off as assets from VMware and EMC for a variety of reasons, but I think mostly to kind of free them up to be a little bit more focused on the future without the so many connections to the existing businesses that the EMC and VMware have, and give us a little more freedom to really go hard at building that future. And now that base architecture has been really adapted and evolved following and everything's been refreshed by Pivotal Labs, which Pivotal has a long history of doing a ton of application development, particularly for startups, but even now more and more we're doing work and partnering with enterprise customers. But the early days of Twitter, Google, Uber, all these places did projects with Pivotal Labs. And so now the project that we have, Cloud Foundry, it's 100% pair programming. It's pretty much test-driven development religiously. They have the strict XP engineering practices. That's just how Pivotal does all their work right now, at least on the lab side. We have a lot of different pockets of engineers that have been left to sort of whatever their cultural practices were. But at least for Pivotal Labs, there's a long tradition of really strict XP practices, and that's the Cloud Foundry team right now.
I see. And so Cloud Foundry, the project, is open source. Yeah.
Cloud Foundry is open source. So there's Foundation. There's on paper about $1 trillion of market cap supporting the Foundation. I've not always been a big fan of foundations in general, if you know anything about me or watch anything. But the way that the Cloud Foundry Foundation got set up, there's some things that were put in place to I think they watched a lot of the stuff that happened with some of the other foundations and some of the other projects, and they tried to put in place really strict stewardship.
Who's they?
The people that were in the position to create the foundation. So James Waters, Rob Mee, it's whatever the executive leadership from Pivotal and whoever agreed to it from places like IBM and HP and the rest of it. But the emphasis is on the functionality and the stewardship of the code, not necessarily protecting people's feelings of inclusiveness.
Right. So who administers this foundation? Is it held by Pivotal?
No. So there's an independent nonprofit organization that was created, and that's really ramping up. And the people that are there are, I said, I was previously very skeptical about Foundation. It's been a pleasure to work with Chip Childers and the Sam Ramjees, and it's basically a organization that is borrowing some of the resources and back end from the Linux Foundation, but then it's also independent. So Sam Ramjee, who I think he's the perfect person for this. He was instrumental at some of the stuff that really got Microsoft set on an open source path. So some of the Codeplex work and some of the early things where Microsoft started to get a clue around open source was really foundations that were laid by Sam Ramjee. And now, you look at what's going on with Microsoft, and I'm shocked to see some of the stuff that they're open sourcing right now. And I don't know, how much credit you can give Sam for that, but I think you have to give him at least a little bit of it. And watching him in Cloud Foundry and the vision that he has for being able to maintain the stewardship of the project, but also create collaboration and community, I'm really looking forward to how that all comes together. And the first event that the foundation's doing is actually going to be a week from today on Monday. It's the first Cloud Foundry Summit that's been run by the foundation, and I'm really looking forward to seeing a bunch of the community share their stories and their successes. They're literally transforming their industries, adopting this technology.
Cool. So this foundation, it's from an administrative perspective, it seems like that's a win. From a user's perspective, the Cloud Foundry is open source, and now it's being managed by this foundation, which would you describe it as more of a meritocracy, or what is it?
I never use that word.
Okay, how would you describe it then? What is?
I don't use words that were introduced into the language as the title of a dystopian novel to describe anything sensible or good. So the way that it's couched in the language is it's governance by contribution.
Right.
Which in most sense, whenever someone's saying meritocracy, it basically means the people who are in charge are going to tell you they're in charge. You never see someone who's not in charge talking about the merits of meritocracy. And with that, governance by contribution basically means that, we want everyone to write the code, and the more code you write, the more code, the more say you get by virtue of the fact that you're writing the code. And in some mental models of what meritocracy might look like, then that could be a very similar model, but it's explicit what is meant by merit in that case, instead of just
good feelings.
Well, I think the problem with meritocracy in general is that merit is defined by the people who have merit. So by definition, they're all oligarchies. They just don't want to realize it.
I see. So this contribution model, then, it has welcomed other community contributions. I mean, is this now a going concern? You mentioned $1 trillion market cap on paper. Who are some of the players? So
this is one of the things that, and this is something that we're trying to fix, and that will segue into, we should talk about Lattice to kind of end this. But the Cloud Foundry as a framework envisioned inside of some place like VMware, having the understanding of what it took to run Google was kind of a all or nothing solution.
Right.
And that is a big pill to swallow if you're a lone developer trying to have an experience. So out of the box right now, for someone to go as a single person without pretty deep understanding of all this stuff and get up to speed on Bosch and doing the deployments and having Cloud Foundry working in a production quality setup, then that's a pretty heavy lift, and that's a pretty big pill to swallow. So the ecosystem that was created, and also because of a bunch of other features that we didn't really talk about that have to do with. So we sort of focused a little bit on the developer experience, and then sort of did this hand waving about operating and being able to do recovery and managing these things at scale. But there's a bunch of other stuff that's built into Cloud Foundry that is specifically there to address things like large organizations and role-based authentication and access to resources and the sophisticated role-based service broker model. And those things make a lot of sense when you have hundreds or thousands of developers and you're wanting to manage hundreds of resources and make sure the right people have the right access. They don't make sense when you're one developer trying to build your next big thing in your dorm room. And so then there's a little bit of a kind of top-down adoption problem that at least my background and the community stuff that I've been involved with in other open source projects makes it so that it's hard to get people excited about something that's like such a huge pill to swallow and has a bunch of features that they don't see the value of because they're one guy in a dorm room.
Right. They can't, even if they wanted to get it going, they couldn't bootstrap. So what's the middle ground there? How do you get those features and still start in the proverbial dorm room?
Well, we're the adoption that you're seeing inside of the enterprise and the people that need that kind of functionality has been, frankly, just it exceeds my expectations. But then back to your point, the features and the technology that's being built to deliver this platform has value outside of the context of that full platform. And we were able to demonstrate that, and this was just announced recently with Lattice. And what Lattice is Cloud Foundry by subtraction, and it is taking away the role-based authentication. It's taking away some of the orgs and the workflows and the build packs, and it's just exposing the container scheduler, this routing layer, this HTTP dynamic routing layer that is keyed off of health checks, and then some operational assistance with log aggregation. And it's also been pared down so that, and the guarantees that you're getting out of the box are maybe not quite so. It's not as resilient out of the box as a Bosch deployed Cloud Foundry, but you're able to get it set up in minutes on Vagrant or minutes on DigitalOcean or Amazon or Google. There's this guy Matt from Cisco just did a installation for OpenStack, so you can do it on OpenStack now too, or you could always do it on OpenStack, but you'd have to have done it yourself. And so that means that in 5 to 10 minutes you could get a little Lattice cluster and start pushing applications into it and seeing that result and having that, whatever the endorphins and the serotonin or whatever that you get from playing with these kind of toys. And I don't know, you've been using Lattice as well. So what is your impression of that, having seen the evolution and the stuff that's available in Cloud Foundry to Lattice?
I like the ability to work in terms of containers. So now I have this very natural way to deploy my applications and move them, manage them, and so on locally. And I sort of wonder, will that experience be mirrored now if I want to go, if I do want to go into this production system inside of a larger enterprise, back in the Cloud Foundry world, what does that look like? What's the next version of Cloud Foundry going to do to offer that same experience?
So what Lattice represents is isolating the Diego rewrite of the Elastic runtime, which has support for Docker, and making Docker the deployment artifact.
Is that the only supported one, or does it support others?
On Lattice or
Lattice
Cloud Foundry?
Or Cloud Foundry.
So right now Lattice is Lattice only deploys Docker unless you really know how to get into the guts of it, and then you can do some stuff. And we saw this today. One of our coworkers did because he made Lattice work on Windows, and so what he did is he used the Windows build packs to build the actual droplet container, and then he extracted that, and then he forced it into Lattice. So there's a little bit colored outside the lines, and you kind of had to know how the internals of some of that stuff works to pull it off. But the fact that he proved you could do it means that you could wrap some tooling around that and make it a little better experience. So Cloud Foundry will not go away from the build pack model, but it will support Docker as a first-class deployment artifact as well. And then there's also probably going to be Rocket support, and potentially the fact is, like, these are really thin wrappers around the C groups and namespace stuff, and so figuring out how you're going to get your metadata for what processes should be run and where you're going to get your file system isn't that hard. There are nuanced differences between the different options. But then going back to something I was talking about earlier, I think it's dangerous to go to a full mystery meat container model. If you don't know what those root file systems are based on, then your potential exposure is infinite. I mean, or as bad as you don't want. And we've had customers that are requesting that the Docker support be turned off, and that was it's trivial to do.
Telling.
But it's also, if you think about going back to the hygiene discussion we had earlier, if you have a bunch of different things that are based on random root file systems and you don't know what those are, and you don't have a great inventory of them that you can algorithmically go and patch and manipulate, then if you have 1,000 of those in production and you have a security concern, then what are you going to do that day?
Right.
Where if you've got a build pack model which guarantees the hygiene by providing a single root file system or a selected subset of root file systems, and then
Curated, maybe?
no, I mean I could build you a hygienic Docker build pipeline, and it would be all Docker, and you could have some of these benefits. It's just that's not the way that a lot of people are adopting this technology right now, and so this guy, exactly what I said earlier, like they're just thinking about day one, like how do I get this as a running process into this thing, but they're not thinking about all the inevitable issues that they're going to have to resolve day two and forward.
So does this does this inclusion represent sort of a hybrid opportunity if you need that drop hatch to escape into mystery meat land? You've got it, but for the 80% case, prefer the hygienic sort of build pack sterilized, you know what you're going to get, we know how to manage it kind of world. And now you can have both of those run side by side.
So the way I would probably want to adopt this if it was my organization and I'm in charge is that you want to have the ability for people to color outside the lines enough to experiment with new technologies and take advantage of the innovation that's possible. But then I would have a little more rigor about what I consider production. So then, that I would be reluctant to put mystery meat into production, but I certainly don't want to limit my own use cases and my own developers when you're doing prototypes and spikes on ideas. So then, to me, it's about getting through, whatever is the fastest thing to validate a thing. I mean, I guess here's the dirty little secret of pretty much the whole software industry is that most of what people have in production are prototypes, and I think that with a little bit more rigor and process, then you can actually do some things that make things, quote unquote production in a way that reduces your ongoing operating costs. So this is one of the things that people talk about in the DevOps movement, and recognizing operations as a competitive advantage. If you think about what it takes to run a service, if there's any cost at all to run a service, then there's always some timeline where that cost exceeds every other cost that it took to develop it.
Assuming the service runs long enough.
Right. That's what I mean, on some timeline.
Yeah.
So if it's very, very expensive to run something, then you exceed that rather quickly. And if it's not expensive, then it might be, heat death of the universe or nearly forever.
Right.
So if you can get a huge impact in your operational efficiency by following some things, even if they might seem slightly inconvenient on the front side, then the payoff over time is considerable.
So for the 80% case then, for the applications, for the things that people are developing, for the 90% case even, that seems to be a very natural way to go, right? You want that consistency. And then perhaps you mentioned prototypes.
For me, this is my personal, like everyone has different sensibilities. Like personally what I would do, I think for production, I would run as hygienic as possible. I would never want to constrain what someone could do on their laptop or what someone could do in the test environment. But then the question is, like, what are the extra steps to take whatever they did and put that into our hygienic process, right? And so going through and saying, okay, well, here's what you did, here's your image, here's these artifacts, and then either creating the new build pack or doing some other thing to get that ongoing benefit, I'll make that investment and kind of keep that pristine, hygienic production environment.
I see. Okay. So, for example, if you're the use case I sort of was attracted to was, okay, I have these ready-to-use images or containers that will get me, Elasticsearch or something like that.
Sure.
And that becomes a service broker in the parlance of Cloud Foundry. That's the mechanism that integrates whatever thing you're trying to run as a service, as a backing service,
Yep.
into the framework that Cloud Foundry can run it. But it is nice to be able to just stand it up for prototyping and get it working inside of a container.
That's great. That's great. Now you have a proof of concept that you could work with Elasticsearch. That service broker works with Elasticsearch, but that is not the same thing, in my opinion, as really operationalizing Elasticsearch in such a way that 6 months from now, when there's a new security patch for Elasticsearch, that you're able to do the right thing effectively.
So you're saying move that to a service broker eventually, or so get it up, prototype, and then move it into the framework, which in that case would be a service broker, like build a proper service broker.
No, it's not about the service broker. It's about the orchestration of the life cycle of that as a service itself. Whether you put it in a service broker or not is sort of an independent consideration. But it's really about, so you pulled the mystery meat Elasticsearch. Now what are you going to do? What do you know what the kernel, or I mean the whatever the dependencies of all that were? Do you know when there's a new security thing what it was? Right? You have a bunch of these things that you can kind of and this is the best way I think of it, and this might relate to people who are really focused on development. Is people get really spun up about things like static typing versus dynamic typing, and why functional programming is better than object-oriented programming, and vice versa. And the difference here is very similar in that if you allow people to just do whatever they want into whatever packaged root file system, then that's kind of like dynamic typing, and
right.
it mostly works, but there's a whole bunch of problems that it causes later, and people have written about their transition from things like the Alex Payne from Twitter wrote a big thing about his experience transitioning from Ruby and to Scala and some of these other typing systems. But if you think about things clearly on the front side, which is what a static typing system forces you to do, then it eliminates a bunch of other problems that you're going to have later.
A class of errors you wouldn't have.
Exactly.
To catch
a class of errors just go away. Like you eliminate that problem by not having it.
Alex Payne, of course, went on to start Bank Simple. So if we extrapolate, if you remove enough errors, you too can start a bank or something. Anyway.
That's how logic works.
Yeah, naturally. We've just looked at Lattice. Any I's you want to dot there? Anything? Any T's you want to cross?
I just think, Lattice is sort of a nascent experiment to try to get Cloud Foundry technology out there. I think that the early indication is that it's a thing that people like. I certainly like playing with it for my own work. It gives you a nice little way to do deployments and really get the power of the scheduling and the routing. There's a bunch of other things going on. Like, this is not a static space, and there's other people working on things that are doing similar things. I don't know how much you want to spend talking about the rest of it, but CoreOS had a CoreOS Fest today, and the stuff they're doing with Kubernetes and some of the other stuff that's going on in both the Docker ecosystem and Rocket and Mesos is just an exciting time to see everyone working on solving these problems, even though they're all slightly different, but they're all kind of the same too.
Do you see it as sort of a validation that we're all at least trying to solve the same problems? That means we're, as an industry, we're in the same space?
Well, the funny thing there is, if you think about the history of Cloud Foundry and Mesos and Kubernetes, in some sense, it represents the diaspora of the Google tooling and mindset, because they all kind of go back to this Google-based lineage. Interesting. Which is why we have containers in Linux in the first place. There were similar kernel-level isolation mechanisms in BSD since like 2000, and I think Solaris had them in 2004, and you get them in the Linux kernel because Google put them there. Well, you had them in the Linux kernel before, but you weren't in the mainline kernel, so you had to apply patches and you had to recompile. So like there's OpenVZ and some other stuff that the people that were doing all the web hosting really like containers, because you could put thousands of websites on a single machine, and since most of them are idle, you don't really have too much problems with contention anyway. So they really liked that technology, but it wasn't in the mainline kernel till Google put it there.
2.6 Is that right? That kernel version?
That's when you first get the first namespacing. I mean, C group stuff.
So that is actually a very old release. It's nice to see a lot of this sort of congealing and becoming, it's now consumable. It's in mass, so to speak.
And we also didn't talk about unikernels, which have, in my opinion, all the advantages of containers, but even more so. And those are, it's like if you have the ability to package your application in such a way that you don't even need any of the multi-purpose operating system features like users or the rest of this, you just want a service that does HTTP and doesn't need to manage a bunch of this other stuff, then I think unikernels are a great approach. And if it follows the same arc as containers, then people will be really excited about 2021.
Interesting. Well, something to look forward to. So these are a lot of different technologies. Where would you recommend people learn more about this stuff if you have a minute to point people in the right direction?
Well, there's obviously all these things have open source. We didn't really talk about the impact of open source, but I think for the most part, infrastructure going forward will be based on open source to some degree. You wouldn't have cloud computing without Linux. You wouldn't have any of this stuff going on without Linux. So I really think that trend will continue. So any of those communities are interesting. I think that it's worth people's time to learn about operations, and the DevOps communities are interesting places to learn about what it takes to actually run this stuff at scale, what it takes to run this stuff consistently, moving faster and safer, more consistent deployments, more rapid deployments, all that stuff's happening. What else is going on? The OSV and Open Mirage projects are interesting if you're into or you want to find out more about unikernels.
Interesting.
And frankly, I think that you're going to see more and more of this in whatever kind of development communities you're in anyway. So you're seeing some of this bleed into the conversations. The Spring group is doing lots of stuff with Lattice now, and that synergy is probably going to increase, not decrease.
Application development is converging with sort of operations, right?
Well, this goes back to the point I was trying to make a little bit earlier, is that at the point where you realize, one of the things people often say around DevOps, and some people give me credit for articulating a lot of this, is this idea of infrastructure as code, and that gives you some insight into how this all works together. But at the point where you're able to provision virtual machines, configure them with APIs, so everything's API driven, from the provisioning to the configuration to adding to monitoring, to doing the deployment, to grabbing the logs, to doing anything that had been done by a person doing a task is replaced by an API. Then all that work that was system administrators running scripts starts to look suspiciously like software development. So the platform itself is software. The infrastructure itself is software.
Software all the way down?
It's software all the way down to the software. And there's, this is a deeper rabbit hole as we don't want to go down, but the software-defined networking, the software-defined storage, the abstractions are going to be available as the stuff that Amazon released with Lambda, the paradigms for how we're going to think about applications and data and the rest of it are going to evolve quite rapidly, in my opinion, over the next decade. It doesn't mean that everything will change. Obviously, people still run mainframes, but that front edge of this will definitely evolve fast.
Very, very cool. So if people wanted to get more of your opinion, are you on Twitter?
I am on Twitter, and that's probably the easiest way to get my attention. My Twitter handle is Little Idea, all one word, all spelled out. And I'm usually, I don't know, people think I'm opaque because I mostly just say whatever amuses me, but I definitely like talking about distributed systems and deployment. And we didn't talk too much about people and process today, but I think that the people are a big part of this. And you don't have software without people, and recognizing that knowledge work is not the same thing as digging ditches is also a big part of this.
we're running well over time. That is definitely perhaps a topic for another episode. I hope you'll consider joining us again.
Well, hopefully we didn't bore everyone to death, but as you can tell from my rattling headphones, I get a little excited about some of this.
Yeah, I can see why. Okay, well, thank you very much, Andrew Clay Shafer, for joining us today. As always, dear audience, we want to hear from you. There are many ways you can reach us. You can comment on the show on our website, se-radio.net, or email us at team@seradio.net. Our Twitter handle is at SERadio. And of course, we're on all the usual social channels, LinkedIn, Google+, etc., software engineering radio groups, as well as on Facebook. Anything you want to leave them with there, Andrew?
It's just an amazing time to be working on this stuff, and I'm excited to be part of it, and I hope everyone will. I think you can always learn more, so just don't stop learning, don't stop building, and thanks for having me.
Thank you for joining us, and goodbye. Cheers.
Cheers.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more information about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can write comments on each episode on the website or write a review on iTunes. Mention or message us on Twitter at SE Radio, or search for the Software Engineering Radio Group on LinkedIn, Google+, or Facebook. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under the Creative Commons 2.5 license. Thanks again for your support.